Welcome to this short video on software update in classic MICROSAR. My name is Sebastian Lerch. I'm Solution Manager at Vector for software update. In this short video, I would like to show you the highlights of our software download stack in classic MICROSAR. Over-the-air software updates are a strong trend in the automotive domain to cope with the increasing software complexity in today's vehicles. There is a high demand in the market to flexibly update the software in the field without having to return to the service center. Reasons for an OTA update may range from a simple bug fix to a security fix or to a temporary or permanent feature enhancement. Let's have a look at how updates are typically applied in the field. Software updates are transferred to the vehicle while driving. Once completed and the vehicle is, for example, in parking position, the driver is asked for consent. The activation or rollout of the software update in the vehicle may take some time. Afterwards, the update is successfully installed. As you can see, a great impact on the driver's acceptance of this procedure is the waiting time. In this time frame, it's not possible to drive. So the long installation process leads to a limited vehicle availability. Let's have a look at a rather straightforward way of updating ECUs over the air. In this example scenario, we have two ECUs A and B that shall be updated. The process is started by transferring the software updates for the ECU A and B to the vehicle to the connectivity unit. The connectivity unit may store these packages locally. The packages or the software updates are then flashed to the ECUs using the standard flash bootloader installed on the ECU A and B. During this time, the vehicle has to be in a safe state. If a failure occurs, for example, when reprogramming ECU B, then the onboard tester has to revert the update and flash the old software again. For this to do, of course, the connectivity has to store the old software that was previously installed. The process again is the same. The onboard tester flashes the old software using the flash bootloaders of the ECUs. Finally, we have restored the old application in this failure case. So as you can see, the downtime is in the worst case 2 times the flashing time of all the updated ECUs. Another approach is to enhance the ECUs A and B with some additional memory and to store actually 2 versions of the software within the target ECU. In this example, you can see that the flash memory of the target ECU is now split into an inactive partition and an active partition. The active partition stores the currently executed application, and the inactive area or partition is ready to receive the new application, the software update. This approach is often called dual or double bank memory approach. Let's have a look at the update process. First of all, the transfer of the software update over the air happens as before, and it is received by the connectivity unit in the vehicle. In contrast to the previous approach, the software updates are transferred to the target ECUs still in application context. So this can happen while driving. The target ECUs receive the software updates and store them in the inactive partitions. To activate the software updates, it's sufficient to swap the partitions. This is then done in a safe state in the context of the flash bootloader. In case a failure occurs in one of the target ECUs, then it's quite easy to revert to the original software by just swapping the partitions again. This is then coordinated also by the onboard tester. So if target ECU B swaps back to the old software, then target ECU A would also be triggered to swap back to the same old software. Finally, if the software is okay and started, then we are back to the original operation mode. As you can see in this approach, the transfer time is now shifted from the save state context to the application context. And it can happen while driving. So the save state time is really reduced only to the activation time. The vector software download stack in classic MICROSAR has several dependencies within the MICROSAR stack. In particular, it has dependencies to the communication or diagnostic stack depending on the OEM protocol. The AutoSAR crypto stack is used, for example, for signature verification or decryption of the software update. Usually, the memory stack is used to store the download state or other state variables in non-volatile memory. The vector software download stack uses vector memory drivers to write the software update to internal or external flash memory. In the vector flash bootloader, the software activation manager is responsible to switch the partitions and therefore to activate the new software. The rollback to the old software is technically the same swap mechanism. A recent feature that we added to our product is the ability to handle multiple controllers or processors within the target ECU. The onboard tester usually sees complex ECUs with several microcontrollers and processors as a single ECU to be updated. So usually the tester cannot see the inner hardware design, so it's just a black box. The software update is received by the microcontroller, which is connected to the vehicle network. Vector software download solution running on the parent node can then distribute the update to the different child nodes. It uses some internal communication channel like private CAN or IPC to transfer the update. And each node is responsible to write the update to its extra memory such that the new software can be activated. To sum up, Vector software download solution in classic MICROSAR supports the OTA update use case by enabling the download in application context. So the activation phase, which defines the downtime of the vehicle, is in the end just the activation time, as the transfer of the update from the connectivity unit to the target ECU can happen in application context. Depending on the hardware capabilities, in the best case, the double memory approach, the activation takes practically almost no time. The software activation manager implements the activation procedure and the switch between the different memory partitions. If the hardware supports the double bank memory approach with AB swap functionality, the software activation manager makes use of it. In other cases, the software activation manager implements alternative strategies like, for example, copying the new software from some external memory to the internal memory. Overall, the vector flash bootloader and the software download stack in classic MICROSAR can support several different use cases. Finally, I would like to mention some highlights of our software download stack in classic MICROSAR. Different OEM protocols are already supported and additional or new protocols can be added easily. To a large extent, the software download stack is OEM independent and therefore we have a high reuse. As shown you before, we can support multiple node ECUs with a complex inner structure. We can distribute software updates to sub-processors or controllers and coordinate the activation procedure. Background programming is a core feature of the stack. The programming process does not interfere with the normal execution of the applications, and the impact can be configured to be as low as possible. The software download stack interoperates with the AutoSAR memory stack, so any excess collisions are avoided by scheduling and prioritizing the flash jobs. The download can be suspended in one ignition cycle and resumed in the next one. Therefore, it is assured that the download, even of large data, is eventually successfully completed. Finally, the software download stack is able to incorporate various data processing and signature verification algorithms. Data processing may include decompression, decryption, or differential algorithms. If you have any questions on our products, please contact us and we can show you more details and advantages of our solutions. Thank you very much for watching this video and goodbye.